we produce 840 kilometres of pultrusion every year on average. We also post-process is sort of one of the other avenues that I will talk about today. We not only make the raw material, we also create product lines and create a solution for customers. As well as the Australian business has been sort of operating for about 20 plus years, over 20 years in Australia. We've recently started up a Texas, USA facility, which you can see here in this aerial shot. So we are now producing our same product and material over in the US to service the North American market and sort of over that side of the world. So very proud to be able to start from a humble beginning as an Australian family-owned business, and then to be able to expand to manufacturing globally, which is a great step for us. Where we service, so typically for the last 20 to 25 years, we've serviced solely out of Australia here. We've manufactured the product and we've supplied overseas, but as I mentioned, now supplying and manufacturing and supplying out of the United States. So we service essentially all around the world, logically predominantly around Australia and New Zealand as our key market area at the moment. Like I said previously, exporting in containers from Australia to the United States, and then also United Kingdom, Middle East, sort of our two bigger areas, as well as through Asia and Africa and what have you, to a smaller extent. What we do, which I'll only briefly touch on here, I'll talk about it later on. We essentially create structural pultrusion profiles out of fibre composite, and we supply them to a range of different product lines or projects, or essentially anywhere that structural members are required. That's where we usually service. So civil infrastructure, electrical infrastructure, industrial, those sort of things. So the traditional materials, so these are obviously quite extreme examples, but the traditional materials typically can suffer in corrosion-prone areas or very harsh environments, which is where the fibre composite in at least the civil marine infrastructure industry has really taken suit, is to be able to combat that corrosion-prone areas. So very high salt environments, acid sulfate soils, what have you. The key benefits of FRP, fibre reinforced polymer, versus traditional materials such as steel, timber, concrete, what have you. I think a lot of people will sort of understand the benefits, but the real key drivers here for us in this civil and marine infrastructure application is corrosion resistance, as I mentioned before. Doesn't rust, doesn't rot, doesn't corrode in all sorts of environments. Acid sulfate soils, high salt environments, harsh alkali environments. It's very lightweight, so about a quarter of the weight of steel for a traditional sort of maybe say a 20-metre bridge, so a structure. It's hard to compare from a metre per metre rate, a standard length weight ratio, because the design is slightly different of how you build up your structure. So if you consider it as a typical structure, about a quarter of the weight of steel structures. The high strength to weight ratio, so obviously lightweight, but we're actually quite a lot stronger than steel in the tensile direction. We're about 610 MPa. For those engineers out there who understand steel strengths, about 250, 350 for sort of your typical yield strengths of steel. So significantly stronger. One of the sort of challenges or things to work with composites in design is the lower modulus. So we're about 40 GPa, so quite a lot lower than steel. So it's just part of that different design of we would typically design around our service limits, so deflection limits for a bridge or a boardwalk, compared to the ultimate strength where you would normally design for steel. Electrical insulating, so I'll talk a bit about electrical infrastructure a bit later on, but that's a key thing for safety in this electrical infrastructure business, I suppose, is increasing safety. So if an insulator on the top of a power pole failed and the line sort of held up against the utility pole, you wouldn't get the touch potential down on the ground, so it is safe. It's insulating from that electrical conductivity, which is a great benefit for light poles or cross arms or power poles. Termite and borer proof, so essentially there's no little issues with any pests or vermin affecting composites like you would expect in something like timber. Is antimicrobial and potable water safe. So essentially we can supply and have supplied into a wide variety of food and water industry. So it's a good little benefit there, and similar to the corrosion issue before, that typically most of the the food processing plants will default to, say, stainless steel, but even that over time will start to get up a little bit of rust. So they constantly have to wash and clean and what have you, whereas this is not really a concern with FRP. So it's a really good benefit in so that food and water processing side of things. One of our key benefits that we're sort of really realizing in the last few years is a sustainability aspect, which is a very hot topic at the moment and very relevant for everybody from all levels, from government all the way down to the contractor level. So we're really proud of our product line and the sustainability aspect of it. We are in the process of just finalising the final verification stages of our EPD, or Environmental Product Declaration. That'll become public very shortly. That really shows the differences between composites and traditional materials from a sustainability and a global warming potential perspective. So as an example, a typical, say, 20-metre long pedestrian bridge, we're about 5 to 7 times less global warming potential than, say, steel. And that's in just a typical environment, 50-year design life where steel doesn't have too much issues. So if you go into the marine environment, our extension of the service life really amplifies that even further. So a pretty typical low risk environment, about 5 to 7 times less global warming potential than something, say, steel or timber. All of that sort of equals up to the summary, I suppose, of a reduced total cost of ownership. So that means low maintenance with the extended service life, particularly in those harsh environments. Low installation costs. So the lightweight means we can transport based on volume, not weight. So you can get a lot more into a truck than you normally would typically, say, steel or concrete. You might use less cranes, so a lot cheaper for the install process. And the maintenance over time significantly reduced. That all adds up to a significantly reduced total cost of ownership for asset owners at the end of the day, which is key for the drivers, key for the councils and utility networks and what have you. So what is FRP, fibre reinforced polymer? So our process is pultrusion. Our two key ingredients are glass fibre rovings. So these are what you see on the racks here. These are rolls of glass fibre. They are essentially our strength. They're where all the strength of the product comes from. And the other key constituent material is resin. So we use a vinyl ester resin. It's a good all-round resin. You can get very specialised resins that have very unique properties, but come at a bit of a premium in cost. Whereas for the civil infrastructure and where our key market is, vinyl ester is a really good corrosion-resistant, very hardy, very long-term sort of a resin. And essentially that holds all those rovings together. It doesn't provide a whole lot of strength necessarily. It just holds all the glass rovings in a little nice, neat package, and that creates our structural material. So the pultrusion process, for those of you who don't know, so very basic overview. Glass rovings, like you saw in the racks there previously, they're the key start to the whole process. Those get pulled through the rest of the line through a series of dies and guides. We apply a surface veil, so that sort of encompasses the whole package. That's a polyester wrap over top of it, and that gives us a nice smooth surface. It creates a resin-rich layer, which helps with things like UV resistance and just helps with that cosmetic finish. Where all the magic happens is the injection in the heater dies. So this is where the resin is injected and flows through the full dry glass package. And then the heater dies cures the resin. So essentially it kicks off a chemical reaction based on the heat, and it cures it. So it goes from a liquid resin into a hard shape. And then the reason for the name pultrusion, it's a pulling process. So unlike something like aluminium extrusion, where you would push a billet of material from the back, we pull all of our materials from the front through. So the pulling mechanisms are a hand-to-hand action. One's pulling all the material through, while the other one's returning back to home and waiting for its turn to take over, and then it takes over and just keeps feeding the whole line. Because it's an automated process, we have the ability to run 24 hours a day, 7 days a week without stopping at all. The material is all continuous, so continually injecting resin, continually tying in glass roving, so the process doesn't stop essentially. So we have an inline saw that cuts off all that material to the specific length that we require. This is a pultrusion machine, so very basic overview. On the back right-hand side is the room where we keep all that glass rovings. That's all temperature controlled, so it's a very consistent process all the way through our hot summers and then our cold winters here in Toowoomba. So all the materials going into the line is very consistent and very manageable. You can see from the back edge, you can see the veil, the injection die and the curing die, and then the pullers. So the two pullers right here in the middle there, and the cut-off wheel. Some of our key points of difference is our glass to resin ratio. So we have a unique method of applying the glass around a centre mandrel called pull winding, as well as our injection die. So typically, normal pultrusion processes would require a bath and glass mats, and that also means that a lot higher resin ratio, which, as I mentioned before, doesn't provide you any real strength. It just holds all the glass rovings, which do provide the strength in the material. So our glass to resin ratio is about 77%, whereas typical pultrusion processes are about 50 to 55%. So as a result, we get significantly higher modulus, which is the key thing, like I said, the key driver in our design. So about 40 GPa elastic modulus in the tensile direction compared to about 15 to 20 GPa in traditional style pultrusion processes. This is a bit of a bird's eye shot of just to show you the transition. So this is a new startup process. When we change a die, we need to pull through all of the glass. So you can see that little transition from glass package dry, and then once we started injecting the resin, that then starts curing it, and that creates this nice hard shape, which then goes through the pulls, and that's just a continuous process, 24 hours a day, 7 days a week, pultruding hard pultrusion. Sorry. And this is essentially what we'll make. So this is the raw finished product. So this is before we post-process, before we turn it into things. This is essentially what you'd compare as a steel mill might have just raw steel off the shelf, or a timber yard might have raw timber just ready to go. Not good for much. You need to do things to it to be able to turn it into products, bridges, bulwarks, and what have you. But this is our core raw material that we manufacture and we produce here in Australia. Based on our unique method and one of our key differences is that pull winding process. We traditionally only make hollow profiles, part of that raw processing. So circular profiles, rectangular, square profiles. But our trick is we post-process and turn it into C-channels, I-beams, angles, what have you, to then do that full range of structural profile. Part of the key point of difference as well for us is being ISO 9001 accredited. So we have a very stringent quality control program that includes raw materials, goods inwards, essentially, our glass, resin, inserts, adhesives, what have you, mechanical properties of our actual raw material, our raw pultrusion, physical properties, weight, dimensional checks, what have you, and then also our post-process, so our inserted material, our bonded material, our coating thickness. So checking every single process down the line to ensure what the asset owner gets at the end of the day is as designed, as expected, and will last that full 100-year design life. Part of our other unique service offering is in-house design and testing. So we have a significant design group. So we do a lot of design in-house to support asset owners or contractors who might not typically be used to designing in composites. We do encourage clients to be able to design themselves, to sort of take out one of those key processes and give the authority back to themselves to design how they would like to design. However, we do have that service to give them assistance along the way, or design and certify in-house as needed. The testing, the key part of that for us is we have a very big in-house R&D department, and that helps us grow and develop into new product lines, new industries, but also be able to back ourselves and understand exactly what our material does in all certain circumstances. So we characterize our material properties, which is part of that design process, is not theoreticals, but true designed and characterized material properties. So you can see a 4-point bend test here in our 301. So we're very proud to have these overheads that typically wouldn't be used in a direct project application. So the quality control process and our R&D, we're very proud to have these overheads on board because it helps us as a business to stay a competitive manufacturer in Australia. It ensures quality and ensures growth and development for a young and growing industry, which is the composites in the structural application. As I mentioned, our raw material gets utilised in a whole lot of applications, but to be able to do that would be post-processing. So we in-house here in factory, we bond it. So we get two square profiles and we will sand it and apply an adhesive, and we'll bond it together to create a bigger shape and a bigger size. we coat everything, so that helps with the UV resistance. So that's another key point of difference that Wagners offers in composites, is to have a UV coating for every single product line that we ship out. That helps to give that 100-year design life. We drill it, we insert it, we assemble it. So as you can see here in the photo, this is assembling a big truss, a side of a truss for a big bridge that was going to go over the rail in Geelong. So we do a lot of that stuff in-house. We can also encourage contractors to be able to do that themselves. We have installation guides. We have supervisors who are available to go on site and help the contractors the first time, just to sort of answer any questions that they might have with the new and unfamiliar material, which at the end of the day is not too complicated or not too dissimilar to traditional materials, but just gives that level of confidence to help support the contractors and the installation crew. So some of the product lines that we do, so as I mentioned, one of our key areas is electrical infrastructure, so cross arms. So for those who don't know, on the top of power poles, you'll see electrical cross arms holding up the power lines. That was sort of our key business for the last 20 years, is our bread and butter, the rinse and repeat. So this is to utility networks, Energy Queensland, so Ergon and Energex in Queensland here, and people like Essential Energy and what have you in New South Wales. So essentially holding up the power lines is the key thing. And more recently, on the right-hand side, we've done the cross arms on top of the traditional timber power poles and steel power poles, but now we're doing our own power poles out of the same material, the composite fibre material, just a bigger and beefier profile to service up to 15-metre utility poles. More on the electrical infrastructure, so light poles, nice parks and gardens and roadway light pole, very aesthetically pleasing, very customisable, which is the key thing. So again, very much hit our sweet spot in corrosion-prone areas. So along marine strips on waterfronts where corrosion really hits the steel hard, or direct burial. So traditional steel light poles will be anchor-based, so they'll be above ground, whereas the composite ones, based on the ability to resist corrosion through high water tables and saline environments, can be direct buried. So it saves a lot on installation cost and time, and also helps reduce that small narrow corridor between footpath and road and what have you, which is getting smaller and smaller, as the utility guys all understand. Ducting, so electrical ducting, this is a recent project we've completed here for Cross River Rail. So again, that insulating material really helps for the safety and environment within the rail corridor. Our automation line, so this helps post-process. This is a bit of a good news story for Australia and Queensland manufacturing. We got some support from the Queensland government to implement this automation line. One of our key drivers, and always a fear around automation in Australia, is the loss of jobs, and we saw that through the automotive industry. But the way we promote it and the way we want to keep manufacturing in Australia is actually bring automation here and upskill our labour. So based on this automation line, we've doubled our capacity in our cross arms, and we've also actually employed more people and upskilled our labour to help support this business. So it's a good news story for us to bring in automation to drive efficiency, but also be able to increase jobs for Australia and Queensland workers. So very good news story, and that's how we believe that working with staff and employees and automation can go hand in hand and increase Australian manufacturing. Civil structural applications, so key things for us is pedestrian bridges. Based on our increased strength and modulus, we are very good at undertaking truss bridges, very long spans, sort of up to 40 metres spans is a good sweet spot, 20 to 40 metres, using either a bolted truss bridge scenario using stainless steel connections, or similar to a traditional timber gang nail scenario, but instead of nails, we utilise rivets. So very similar traditional style bridges, but using composite instead. Girder bridges, aesthetically pleasing, sort of Japanese style bridge on the left-hand side. Road bridges, so again, based on our higher strengths compared to normal traditional composites, we can get into road bridges, very high loads. This is an example from a 2004 bridge and a recheck in its first winter on the right-hand side from Buffalo in New York, upstate New York in the US. So this had a key issue where the traditional concrete bridge was spalling out based on de-icing the roads using salt. So the composite scenario was very good for this application, and nearly 20 years on, it's still performing just as good as day one. Boardwalks, this is in Ocala, Florida. Very traditional sort of stick build, very timber-esque, I suppose. So we can make the material look very similar to traditional while also giving those extra benefits for the longevity. Boardwalks and more boardwalks. So this is in Abu Dhabi. So we like to pair up with materials to suit the aesthetics. So this is obviously a rope balustrade and timber decking, what the clients want. So we're suiting what the aesthetics requirements are, what the clients would prefer to see and visually use, while also having the substructure long term. So the corrosion prone areas in the piles or the bearers or the boardwalk substructure, all composite, but the aesthetics looks like a traditional timber and rope balustrade boardwalk. Typical clip-on bridge on the side at Wollongong, Grand Pacific Walk. Stairs, so utilising that same truss bridge scenario for a set of stairs into water near a shipwreck in Western Australia. Genjuk stairs on the left-hand side, so the lightweight helped with this one where we could helicopter that structure in situ, so we're battling against the tide. So we built parts of the structure off-site, helicoptered them straight in, bolted them, and then could get out of the way of the tide, and quite an impressive tidal zone there and quite harsh environment. So a very good example of that lightweight nature. Marine structures, again, the very corrosion-resistant nature of materials works very well for jetties, pontoons, what have you. Marine piles, lightweight, makes it very easy to install. This is on the Pinkenba wharf in the Brisbane River. So this is our clinker cement mill in Brisbane, using a composite substructure and an earth-friendly concrete topping slab. Water industry. So this is potable water. So as I mentioned before, antimicrobial and potable water safe. And then more in the industrial aspect of roof purlins. So again, that corrosion-prone area where something like iron ore would very much rust out traditional steel purlins. So the composite is very good in application and pairing up with composite roof sheeting. And then to help asset owners and designers, we have a design guide. So part of the questions we usually get is how do we design in composites? There's no Australian standard yet. So we provide a design code, a design standard that is reflective of international American standards and also in line with utilising Australian and New Zealand load applications. So you take AS 1170 for input loads or AS 5100 and you design it just using a few different factors to suit composites, but generally a similar process to how you design other materials. You just might focus on service load based on lower modulus versus strength where we've got a higher strength. So that's available online and we are available to do some deep dive webinars with the designers or asset owners who would like to get into more details around designing. So those are available in this similar series as well. So please reach out if you've got any questions about designing in composites, and we're happy to help provide our structural and our certified engineers to help assist you with that. The very brief overview for now. Like I said, there is more webinars coming for us to dive in deeper, but very brief overview for you guys, and appreciate the time to listen to the quick run through of what we do in Wagners CFT and how we produce a bespoke and different composite material for your structural application.
Good on you, Lockie, and thanks so much for that. Just to give Lachlan a couple of minutes to have a look at those questions that are in the chat. I'm just going to share my screen now, and we're just going to talk through two very quick slides to give him a chance to have a look at those questions. So Wagners Holdings is an Australian stock exchange listed company. It was established in Australia by the Wagners family in 1989. The business now boasts more than 1,000 employees in 7 countries, with manufacturing facilities in Australia, the US and UK, and supplies construction materials and services globally. There's 3 main business units, which includes the Wagners Construction Materials and Service Division, which includes cement, fly ash, aggregates, precast concrete, reinforcing steel and bulk haulage services. We've also got Wagners Composite Fibre Technologies, which we've been discussing today, and Wagners Earth Friendly Concrete. Wagners Holdings is still very much a family business, with Joe, John, Neil and Dennis Wagner actively involved in day-to-day operations. So we're going to jump over to the question and answer section very quickly now. And I'm going to hand back to you, Lockie. The first question that we've been asked from Peter D, what cleaning chemicals are likely to affect the resin?
Good question, Peter. So yeah, so key thing for composites using that vinyl ester resin is there's not many chemicals that will affect it at all, and they have to be very, very high dosages. So any general cleaning materials or acids or what have you won't affect our material at all. So very safe in that aspect from a maintenance perspective. So it's just then generally the easy thing, because it's what we use is an anti-graffiti coating from another Australian supplier, A&I Coatings here in Sydney. It's an anti-graffiti coating, so it's very easy to clean. So if you've got a structure, say in a graffiti-prone area, it's a good soapy water clean over, and that's generally all you need. But if you were to use harsh chemicals, it's really not a concern at all for our product line. Good question.
Great. We'll go to the next one. Ben Brady has asked, how sensitive is the material, the resin and or the glass roving, to UV exposure?
That's a good one. So that is one of the key things, I suppose, to consider when you're looking at fibre reinforced polymer, is that UV is one of the things to look out for. It is one of the negative effects, I suppose, on the material. So what we do is we coat everything, so to prohibit any UV exposure long term. Traditional materials are typically using UV inhibitors, which does help for a short period of time, but everybody knows here in Australia how harsh the UV is, so that just doesn't last long enough. So we make sure everything is coated that goes out the door, and it's a two-pack paint, like I mentioned before, which is quite easy to update if you get a little scratch or what have you, and that helps to extend the life. So yes, key thing with composites is to make sure you coat everything. That way it gives it that full 100-year design life, instead of just using the reliance on the inhibitors through the pure resin.
Couple of questions from Steve Pottinger. He's asking us, what are your circular sizes and how strong do the screws hold in the purlins?
Sure. So we have a broad range of circular sizes. I won't go to every detail, but essentially our smallest size at the moment is an 89mm round, and we get up to a 300mm diameter round profile, and everything sort of in between. We have new tooling on the way for a 356, and then our machines have a capacity for up to a 400 diameter pile, which is brilliant for utility poles and marine piles. So if anybody wants to know the exact sizes, the product guide is the best place to look there, and that'll have all the mechanical properties, the thicknesses, the sizes, and what have you, and all the mechanical properties. So if you do want to find a specific sizing, just have a look at that product guide, which is available on our website. I think Kelly's even put in the chat here, so the links will be there to find out the exact sizes. But current range is from 89mm to 301, and within that. The screws, so we've done testing through the university up in Townsville, James Cook University, to check against cyclone loads, so fatigue loading. So that report is available if required using the purlins. So it's a key thing that we needed to check off in that environment, is that cyclonic use and that fatigue loading. So there's some good testing to show how well those performed. Our normal screws we normally suggest would be a coarse threaded timber screw, and they hold very well in our material, which we can show some testing for.
We've just got 2 questions left there. Lockie, any more questions that come in, we'll take on board and circle back to the owners of those questions after the webinar today, because we'd love to continue doing question and answers for ages, but we will have to try and keep a little bit to our time frame. So Neil Lawson just wanted to know, do you manufacture components with different wall thicknesses depending on application or required strength?
Yeah, it's sort of yes, sort of no. So we do. So we the challenge, I suppose, with the pultrusion process is it's not super easy to change wall thickness depending on a case by case basis. It's very similar to that extrusion process with steel. We need a set die. So we do change the die dimensions depending on applications. So if we have a lower strength utility pole to look at, we will change the wall thickness to suit. So we have that right now. We have a light duty and a heavy duty version. However, it's not just a quite an easy chop and change scenario a small little project here to change the wall thickness. So we have a broad range of what we can do, and we try and use the best profile for the application to suit. So we focus more on that design aspect, using the profiles to suit, rather than changing every single thing that we do. So very similar to steel, you just pick the right dimension to suit your design, essentially. And then the next one would be folded.
Last question. Yeah, thanks.
Cool. So that is another one of the challenges with composites. The resin we use is a thermoset, so it's essentially once you cure it, it can't be post-processed itself. It can't be folded necessarily. It'll crack and break. It can't be welded to. The type of resin that you would use for there is thermoplastics. That's part of our R&D venture in the next little while, is to investigate that. However, what we utilise now instead is utilise stainless steel connections. So 316 stainless, which pairs up very well with the corrosion resistance of composites. We utilise those for any folded brackets or bolted connections to pair up with it. So they're a minor part of the structure, but it just helps us with our customisation of structures, with the slight limitation of composites where you can't fold them or weld them necessarily, with our process at least.
All right. Well, thanks very much. We're going to wrap it up there today. I think, Lockie, you're comfortable with that?
Yeah, good. Yep. No, definitely. Like Kelly said, we'll reach out. Any other questions, feel free to shoot through, and we'll answer as much as we can and get back to you.
Right. I've just popped the link to the feedback form in the chat. We really appreciate you completing the feedback form so that we can continue to improve on our webinar series. And I just wanted to remind everybody as well that the next webinar is the 23rd of August, and I will pop the link in the chat for anybody who's interested in signing up to that webinar as well, with Darren Wilson and Danny Lynch from Townsville City Council, and that one will be on pedestrian boardwalks and bridges. So look forward to seeing you there. Thanks very much for coming today, and we'll see you next time. Thanks now.